Hello, and welcome to our bite-sized presentation entitled Climate Change: How Can Church Buildings Be Best Adapted to Meet the Challenge? My name is Mark Eddison. I'm an architect and director of MEB Design. We are architects with offices in London, Oxford, and near Maidstone, Kent. Climate change is a mainstream issue, and as you may know, architectural and heating and ventilation services design choices have big parts to play in reducing CO2 emissions, particularly when it comes to existing buildings. As a firm of architects, we have committed ourselves to the RIBA Climate Challenge 2030 and signed up to Architects Declare. I'm joined by Dr. Joel Callow of QODA Consulting. He is Technical Director of this Design, Engineering and Building Services consultancy firm based near Oxford. We in QODA find ourselves working increasingly together on existing buildings, trying to address this issue. This talk looks primarily at existing church buildings because the Church of England recently issued a challenge for its estate to become net zero carbon by 2030. It is a huge but serious challenge, and hopefully one which other denominations or church streams will consider, if not already. Just to point out one thing, we are not discussing embodied carbon in construction during this talk. A separate concern. This one is about energy use. So to whoever you may belong, we will briefly address 5 questions around the impact of church buildings on the environment, which are: what does net zero carbon mean with respect to climate change? Is change possible and where to start? What built options are there and what maladaptions should be avoided? What financial considerations should be explored? Who to consult and where to get advice? To start with some answers, I will hand over to Joel to address the first 2 and let him set the global scene around church buildings and climate change.
Thank you, Mark. Okay, let me give you a brief introduction to climate change, and we're going to look back in history, see where we've come from, look at the present, and then see what the future might hold. So you're probably aware that at the moment, globally, we are about 1 degree warmer than we were in pre-industrial times. How have we got to that point? Well, if you look at the slide on the screen now, you'll see that our carbon emissions, our carbon dioxide gas emissions through fossil fuels, have been going up and up and up over the last 200 years since the Industrial Revolution. And they've grown really very fast in the last 50 years, up to the total at present of around 35 billion tonnes of CO2 per year. It's not the only fossil fuel that's contributing to climate change, but it is the main one. So if we're going to address our climate future, we need to start with carbon dioxide. You might wonder who has contributed to the carbon dioxide we've emitted so far. Whose fault is it if you want to point the finger? Well, I'm afraid the finger points back at us, at Europeans and North Americans, who've emitted in total over half of the carbon dioxide that's now in the atmosphere and has been emitted there since 200 years ago. So that's where the carbon dioxide has come from. But what about the present day? Who is currently emitting carbon and where? Look at the slide on your screen now. You'll see that the picture has changed slightly over time. So cumulatively, North America and Europe are dominant, but today Asia is dominant and emits more carbon than anyone else. But we're really concerned about church buildings in the UK today and what we can do to bring them to the zero carbon target that the Church of England has set. So this pie chart on screen now shows us that buildings are responsible for something like 30% of global carbon emissions. And if you allow for construction of those buildings as well, it's more like 36%. So over a third of yearly average carbon emissions are from buildings of some kind or other. And you'll see that non-domestic buildings contribute 8% of that total. So it's not the largest contributor, but it is a very significant number and one that we need to take seriously. The present situation is that buildings are a major contributor to climate change, over a third. And how does that pan out over the coming years? Well, if you look at the slide on your screen now, you will see projections forwards into the future of our carbon emissions and the climate change result that comes out at the end of that in 2100. You'll see some rather uncomfortable looking lines upwards and red. Those are telling us what would happen in a very worst case scenario with perhaps 4 degrees or more of average global warming across the planet in 2100. But more encouragingly, there are lines heading down the graph. Those are the lines where we reduce our carbon emissions rapidly, ideally from now to 2050 hitting 0. And then from there, we see outcomes in 2100 of 1.5 degrees warming, which is the scientific consensus at the moment where we need to try and get to, or perhaps 2 degrees as a worst best case, if that makes sense. Okay, so we need to rapidly reduce our carbon emissions across the globe. And that means we're hearing the phrase net zero carbon, including from the Church of England with the 2030 target, increasingly frequently now. But what does net zero carbon mean? What does it mean on a large scale? And what does it mean for us as users of church buildings around the UK? Well, let's look at the big picture first of all. If you're thinking about net zero carbon as a global issue, which we need to, and which we need to drive down to zero by around 2050, then what we're really talking about is stopping drawing up oil and gas and coal from the ground, the fossil fuels we currently rely on, and instead swapping wholly across to renewable energy systems. On screen now I've pictured wind turbines and solar panels. We think of wind turbines as perhaps the most likely and common renewable energy system because we live on a small windy island. But actually globally, solar power is much more likely to be the dominant technology that we'll use for renewable energy. In practice though, we'll use all of them in different quantities in different places. But we need to use those increasingly until we only use those in 2050 and we don't need any fossil fuels at all to give energy for our global lifestyles. So that's what it looks like in the big picture. Net zero carbon means no fossil fuels and it means all renewable energy. But when we focus down on individual buildings, for example churches, the picture does change slightly, especially in the next few years before we get to 2050. So net zero carbon in buildings means a kind of balance. On screen now you'll see a weighing scale, weighing up the energy we use on the one hand, so the stuff we consume, the thing we pay our electricity bills and our gas bills for, and on the other, the renewable energy that our buildings generate through the systems installed in them. Some of our buildings don't have any renewable energy, others have a great deal. And in order for us to push our buildings towards net zero carbon, we need to make that balance change so that our buildings generate more renewable energy than they consume. And when we hit that balance, then we have net zero carbon on a building basis. So we need to achieve a balance between the energy we consume and the energy we generate from renewable sources. But there is something encouraging going on in the UK at the moment that helps us with that particular challenge. We get quite a lot of the energy in our buildings from our national electricity grid at the moment. But if we cast our minds back 40 years, as you'll see on the slide now, we find that our electricity grid was quite high carbon back in the 1970s. At that point, our electricity came largely from the burning of coal. We dug up a lot of it, we burnt it in our power stations, and it generated the electricity we needed. The problem was coal was dirty, and it generated a lot of CO2 per kilowatt hour, per unit of electricity that was generated in those power stations. Fast forward to 2010, however, and it's already down to just 500 grams, which is still more carbon than we'd want, but it's a lot better than it was in the 1970s. Better still though, today in 2020, the average carbon content of our grid is around 200 grams per unit. So it's really come down fast since 2010. That's great news. That's because we've switched off coal and switched on a lot of wind turbines and solar power, but there's still further to go. The UK government projects that we might be down as low as 100 grams per unit by 2030 and as low as 0, so a net zero carbon electricity grid, by around 2045. So as building users and as people concerned about the carbon footprints of our church buildings, this is really good news. Before I hand back to Mark, let me just give you a couple of resources you can look up as you try to plan your journey from here to net zero carbon. First of all, the Church of England has a really excellent carbon footprint tool, which you can find on their website, which will help you to calculate what your church building is currently emitting. It will do that per square metre, to do with the size of the building, but also per person hour, to do with how intensively the building is used. So that helps you to figure out what sort of baseline carbon emissions you're facing with your particular church building, because they are all different. Once you've measured it, the next step is to create a plan. And on the slide on your screen now, you'll see a plan we created recently within QODA for a client who was trying to get to zero. You'll see that they got down low in our projections by 2030, and then they hit zero in 2045 as the grid decarbonises. But it was a step-by-step phased plan for their building. So each building will need its own plan and its own kinds of interventions that are bespoke to their situation. Let me hand back over to Mark now to tell you more.
Thank you, Joel. Joel has defined where church buildings need to get to. Energy used must equal renewable energy generated on-site and or off-site. As there are green suppliers such as BULB, Bulb and Ecotricity, a start can be made, and one thing you could do immediately is review who your electricity supplier is. But to get towards net zero carbon, we must develop a plan. And to plan we need a good understanding of how much energy your church building uses, a clear understanding of where the opportunities and problems with fabric lie and when you might deal with them, and a thorough examination of the options there are and the costs involved. Then a roadmap and a funding strategy can be developed. A good understanding of where your energy use starts begins with good data. Joel has directed us to one helpful tool, to the energy rating of your building as a baseline piece of information to know how bad or good it is. Here is another produced by the Church of England. There will be other tools. Sometimes a helpful one is infrared photography. This can tell you clearly where energy is going. In this image, mostly through the roof. And you need to know the condition of your fabric and when will be its time for renewal, because the best time to upgrade is when fabric is replaced, like the roof coverings or boilers. Then a careful look at the realistic options and evaluations should follow. So what are these options if Joel is to balance his scales? Two considerations. What can we realistically do to the fabric to reduce heat loss? What renewable energy options might be possible and affordable in my building? Terms used to describe improvements to existing fabric have become increasingly familiar, and it's where an evaluation of the options can start. You might typically, in a modern building such as this 20th century church, consider increasing the insulation of walls, floors and roof, in cavity walls if they exist, or internally this will mean the loss of floor space. Upgrading doors and windows, such as secondary glazing or double glazing. In this building, many windows have actually been replaced. Draft stripping around windows and doors to reduce air leakage. Introducing draft lobbies. Changing to LED lights, something which is quite well understood now. And insulating heating pipes and installing more efficient boilers. As most church buildings are gas or oil fueled, the source of heating is a particular challenge if our renewable future is being shaped to decarbonize the electricity grid and move away from fossil fuels. Air source heat pumps are powered by electricity and combined with a lower level of heat intervention through, say, underfloor heating are being increasingly considered. There are other options, biomass heating, based on the presumption carbon dioxide released by burning wood equals the carbon dioxide fixed by trees as they grow. But this system is less favoured today than 10 years ago, probably because it does not actually reduce levels of carbon dioxide overall. But you need to be aware, old buildings, such as this one illustrated, cannot be treated in the same way as newer buildings. It is much harder to upgrade the fabric. They behave differently, clever in the way they handle water, and many are heritage listed, adding to the challenge of obtaining faculties, listed building consents, and in some cases planning permission. Here is a picture of how an old building works environmentally. It is designed to be breathable, with no barriers to moisture movement, and with a reliance on internal air movement. Care and understanding is needed if you intervene. How might your organ, for example, fare if the environment becomes significantly drier? And take insulation. How do you improve thermal efficiency if this stops the fabric from breathing? If you dry line without thought, moisture will find its way and express itself somewhere, often not where you want it. We have recently started to use an internal breathable lining, lime green warm shell insulation, which does breathe and would be suitable for historic walls. And if you add insulation to roofs, you will have to be very careful not to introduce condensation in the wrong places where it will be hidden. Floors are even harder to insulate unless they are being renewed, as here. But again, the solution has to be breathable. As the original design requires good internal ventilation provided by drafts to remove moisture buildup, draft stripping may be damaging, and common secondary glazing will increase condensation on fragile leaded glass windows. Then if you think you're about to change the heating system to use electricity using an air source heat pump, the visual impact of an external location must be carefully considered. So there is much to think about. Once you have a plan for the fabric, the next question arises whether renewable technologies might be appropriate and when should they be installed. The most likely renewable source will be the now familiar photovoltaic panel. But with these, there are loading considerations to check, orientation to check, and the visual impact, particularly difficult on listed buildings, where statutory authorities will have to become less stringent. And costs. Funding will be the biggest challenge, I suspect. You may find it helpful to carry out a cost-benefit analysis on your plan in order to refine it and understand what benefits arise from what you spend. It can also help you understand what time will be required to pay back the money you invest from saved running costs. There is no magic wand. For example, if you install PV panels now, you will have the incentive to sell the electricity you generate back to the grid. But as time moves forward and the grid decarbonizes, the incentive will reduce till it ceases to offer any return once the grid becomes carbon neutral. You may ask, why not wait till the grid is carbon neutral? But I'm ending by saying there is an overarching imperative to do what we can now to reduce CO2 emissions. Thank you for listening to Joel and myself. We would obviously be very pleased to help any church community think through these issues if and when you think it is appropriate.
Nothing beats sitting on it, hearing it, tasting it, wearing it, handling it, trying it, comparing it.
The copier produces 1,000 copies for £4. The Riso digital printer produces 1,000 copies for £1.20 at 140 pages per minute.
Discussing it.
The interesting thing about this centre is it's a very difficult breed, so on a very small site.
Buying it. Recommending it. I definitely recommend it.
It's always good to have resources, and yeah, this is very resourceful, so it's a great place to be.
Nothing beats being here. Buy your tickets online now. creonline.co.uk/tickets.